Okay, today we're going to look at the laws of logarithms. And in Canvas, I have posted a logarithm cheat sheet. So I would recommend you have that open or downloaded or somehow in front of you as we go through these, because I will reference that. So we'll just get into examples because this section is really best served by examples. So for the first couple, they just say evaluate. So this means calculate what this value is. So I'm going to use the laws of logarithms, so that there's a little box on that cheat sheet. And for this first one, I'm going to use law number 1. So what that says is that if you have two logs added like this with the same base, you can multiply the interior of the logs and write it as one logarithm. So I would have log base 12 of 9 plus log base 12 of 16 would be the same thing as log base 12 of 9 times 16. And let me move this a little bit. So then that would be log base 12 of 144. And that's saying what power do you raise 12 to get 144? And that would be 12 to the power of 2. All right, so the next one, it's another evaluate. So you'll notice it's log base 3 of 100 minus log base 3 of 18 minus log base 3 of 50. So I will look at the law 2 on the cheat sheet, and I will write this as one logarithm, but I will write it, I'm going to do this in 2 steps, even though I could do it in 1. So this would be log base 3 of 100 divided by 18 minus log base 3 of 50. And then we just apply that same property again, because now we just have a subtraction of 2 logs. So we're just going to go ahead and write that as log base 3 of 100 over 18 divided by 50. And I will highlight one thing. I think I've stated this before, but if you have a fraction divided by a number, you can just view it as one number and you can factor it out. This is the way I think of it. So this is the same as log base 3 of 100 over 18 times 1 over 50. It's not essential that you do this, but if you don't do this, you have to go through the whole division of fractions routine. So it's a little easier. Cross out the 100, turns to 2. And so this logarithm is equal to log base 3 of 1/9. And again, these are asking what power do you raise the base to get the interior function? And this would be -2. And just to remind you, 3 to some number is going to equal 1/9. 3 to some number, the 1/9 I will convert to a base of 3. So 1 over 3 to the second, I'll put that in the numerator, and that exponent becomes negative. So that's where that -2 is coming from. Okay, so we have evaluate log of 10 raised to the 10,000. So when the base is not stated, we assume it's 10. And so just like any other problem, we work from the inside out. So I'm going to first work with this log of 10 raised to the 10,000. So I would have log of 10. I'm not going to write that 10 over and over again. So this is log of, inside I can bring the 10,000 into the to the front. So it's log of 10,000 times log of 10. And log base 10 of 10, if the bases match, it's always 1. So this is really just log of 10,000. And the question is, what power do you raise the base 10 to get 10,000? And that is just 4. Okay, so the next few problems, we're going to be expanding logarithms. Then we're going to combine logarithms, which is just doing the going back and forth. And yeah, so we'll start here. So expand log base 3 of 5y. So inside of this logarithm, you can see I put a little dot. 5 times y, that is multiplication. So we can write this as 2 logs with an addition sign between them. So this one just turns into log base 3 of 5 plus log base 3 of y. And since we have no exponents, we have nothing multiplied inside the logs. That's how you know you're done. All right, let's go to this one. So when you have radicals or anything like that, what you want to do is first write those as exponents. So it says expand log base 5 of the cubic root of x squared plus 1. So I will first write that as log base 5 of x squared plus 1 raised to the 1/3. Now we're going to apply our laws of logarithms. So if you look at your sheet, the laws of logarithms number 3 tells us we can bring this exponent down to the front. So it's now 1/3 log of 5, or log base 5 of x squared plus 1. So with these, we have a inside of the logarithm, we have an addition problem. But if you look at the laws of logarithms, we can't expand this further because the addition has to be between logs. It can't be inside of the logarithm. So when things are multiplied inside the logarithm, we can split them apart. But if they're added or subtracted, that law doesn't apply. So this would be complete. All right, so let's do another expand. This one you can see log base 10 of x cubed times y to the 4th divided by z to the 6th. So we're going to have, how many logs here? Well, we have 2 things multiplied and then they're divided. So we're going to have 3 logs at the end. I'll do this in 2 steps. So in the numerator, I can separate those with an addition sign. So now they're log of x cubed plus log of y to the 4th. And we have z to the 6th in the denominator, so that would be a subtraction of log of z to the 6th. And then we look at it, do we have exponents? Yes, so we bring those down. So this would be 3 log x plus 4 log y minus 6 log of z. And that would be it. Okay, so let's do the combined ones. So now we're just going to go backwards using those same laws. So if we have an addition of logs, we can write those as 1 log. First, we have to put all of the constants back, or back into the exponent. So this one says combine these two. So log base 3 of 5 plus 5 log base 3 of 2. I'm going to make that log base 3 of 2 to the 5th. And since that's a small number, I'll just calculate it. So log base 3 of 5 plus log base 3 of 32. And then I can write those as 1 log. So log base 3 of 5 times 32, which is 160. And that would be as far as we could combine them. Okay, so we can do the same thing with natural logs. Doesn't matter if it's natural log or log. All right, so we have 3 different logs. So this is going to end up like a previous example where we're going to have 2 things in the numerator, 1 thing in the denominator. So first of all, I have to put back that exponent. So log base, or natural log of a plus b plus natural log of a minus b minus 2 times natural log of c. The 2 needs to go back. So I'll do this I'll try to do this in as few steps as possible. For the first 2, I can combine those into 1 log. I can multiply those. So a plus b times a minus b. And then that will be minus natural log of c squared. the first log, so I have a plus b times a minus b. That is a difference of squares, so I can combine that to make it a squared minus b squared. And this minus natural log of c squared, that means the c squared is going to be in the denominator. So I'm using both laws 1, 2, and 3 in this example. All right, so it doesn't take too much to make these complicated. Here's a more complicated one. I think this is the last ones of those. Yeah. So we'll just go slowly through it. So it's 1/3 the log of 2x plus 1 plus 1/2 parentheses log of x minus 4 minus log of x to the 4th minus x squared minus 1. So this is a looks messy, but if you go slow, it's just applying the same laws over and over again. So for the first part, we'll put the 1/3 back. So it would be log of 2x plus 1 raised to the 1/3. With the next part, this 1/2 I can't put back yet, so what I'll do is first work with what's inside of the bracket. So inside the bracket, we have a subtraction sign there. So I can write this as 1 log. It would be log of x minus 4 divided by x to the 4th minus x squared minus 1. That's all inside that log. And I have to do a couple things here. So this 1/2 I can now put back into the exponent. So I have log of 2x plus 1 raised to the 1/3. And then this would be plus log of x minus 4 divided by x to the 4th minus x squared minus 1 raised to the 1/2. Okay, so now I'm combining this one, so I will have exponents in the end. Those have the same base, so I can now combine those. So this would be, when I do this next step, I'm going to write these as radicals because it looks a little better, but you don't have to. So it'd be log of the cubic root of 2x plus 1 times square root of x minus 4 divided by x to the 4th minus x squared minus 1. And I have one logarithm, so I've combined it, and all my exponents are inside of the log, so that would be the final answer. Okay, so the change of base, this is kind of an older idea because calculators now change a base really easily, but it wasn't always that case, and it wasn't even that case when your book was written, so this is still included. Basically, the only reason you change base is to change it to base 10 or base E, because those are the buttons we have on a calculator, and that's what they're programmed for. But if you didn't have that, you use the change of base formula. I'll actually write this one down here. This is log base b of x equals log base a of x divided by log base a of b. So the expression on the left, log base b of x, this one, that is the target base. So we want, no, that's the starting base, I'm sorry. So in this case, our b value is 2 and our x is 5, just as we fill that in. So then we're just converting it. So I'm going to make this base 10. So I would say log base 10 of x, which is 5. So log of 5 divided by log of 2. So if we look at one more, I'll just tell you the way that I remember this formula, because the actual formula here, this is one I do not commit to memory because that is a lot of wasted I need that space. So if you look at this second example, log base 6 of 92, physically on the digital page, 92 is above 6. So I look at that like, well, that's going to be above 6 in the fraction too. So all I need to remember is that whatever base I want, so I want base 10. So then I just put the 92 over the 6. So it would be log of 92 divided by log of 6. And you could commit this formula to memory, but that's not a good one to commit to memory because you don't use it very often. So when you work on this assignment, just make sure to use your logarithm cheat sheet because that'll make it all a lot easier.